Perfect. Oh, okay. So welcome back everyone to another episode of Paths Uncovered, the podcast where we get to talk about untraditional pathways into technology and even within technology. So I'm very excited to have Linda McIver as my guest today. I think I still remember the first time I met Linda, which was at like a random event. I think it was like Our Ladies Melbourne, something similar to one of those meetups in Melbourne. And honestly, she went and talked about what she's been doing at the moment, and I have been in awe ever since. So this has been a long time coming chat. It's our second round at this because we kept having connection issues, but I'm hoping that this goes through and we can actually chat about everything and get to hear all about Linda. Welcome, Linda.
So nice to be here. Thanks, Akansha.
No problem. Right, okay, well, I feel like this is a kind of like deja vu because I feel like I did all the same exact thing, right, but like 3 days ago, and I'm like, okay, let's just try this again. But if you want to introduce yourself really quickly and we can settle in and get started.
Sounds good. So I am Linda McIver. I am the founder and executive director of the Australian Data Science Education Institute, which is a charity dedicated to building the data science and data literacy skills of all Australian children. Ultimately, all children around the world. But, give me a week or two.
Just about that. Like, I mean, no more than 2 weeks and you'll be out there doing it all, right? Exactly. No, and I think it's just such an important part of everything that it is right now, right? The way we are, data is just everything at the moment. It's so important for people to be able to understand what they can do with it. Right, okay, look, we're going to talk all about that as we keep going. So let's dive in. Take me back to kind of high school, college. What was happening back then? What were the original career paths that you saw for yourself?
So my first plan was I wanted to be a vet.
Yep.
And then when I was in like year 10 or year 11, I think I found out that I'm allergic to pretty much everything. The immunologist was like, yeah, that would kill you. And then he laughed. And I was like, that's the least funny thing I've ever heard. And then I applied.
Stop laughing.
Yeah, it's funny now. I don't regret it for a second, but it was a bit heartbreaking at the time. Then I had medicine as my first choice, and I didn't get in. And that was probably the best thing that ever happened to me. I went on and did a generic science degree. And the great part was there was one, I needed a fill-in subject in first year because I wanted to do genetics, and for that you had to do biology, chemistry and maths, so that was kind of 3 of my 4 choices. And I had I had a space, and so I thought, wow, I kind of like playing with computers. My cousin Chris gave me his Commodore 64 when I was little, and I played with that, and I made little basic programs, and it was really satisfying, and getting through the frustration and getting it to do something I wanted to do was amazing. So I was like, okay, I'll do computer science. And I actually hated first year. I don't know why I was still doing it in second year. But by third year, it was the only thing I was studying.
That is amazing. So and it's so interesting, honestly. I was the exact same, where I thought I was going to do medicine, and I was like, I'm so glad that never happened. So thankful for it now. But yeah, so by third year, it was kind of like, this is exactly what I want to be doing.
Well, third year was where all the interesting stuff was. So there was artificial intelligence and image processing and graphics and funky sorts of programming. And it was I was kind of holding out for the good stuff in third year. And yeah, I loved it. Then I went and got a job in a software company, and the software company was a nightmare. It was one of those, it was a little startup where the boss was having screaming matches with the other boss, who was his dad, in the middle of the office. It was
unreal.
It was
just
not a happy environment.
Yes, exactly.
Yeah, exactly.
Professionalism.
Right. I was kind of miserable. And some friends of mine who were doing postgrad computer science said to me, well, you should come back and do honours. And I said, well, I didn't get the marks. They were like, there's ways around that. And there were ways around that, as it turns out. And this was my first lesson in, if you want something badly enough, don't let the obvious barriers throw you. So, if you don't get the marks, there will be ways to get around it, whether you do something else and then transfer, or whether you badger the right person and get in. There are
enough ways. I love that. I was just going to say, everyone needs friends like that, where they're like, we got you. We'll sort it out. Don't you worry.
That's exactly right. And that was really the first time where my friends were instrumental in changing my life, and where I realized that I wasn't doing any of this alone. You know, I had friends who had my back and who were going to help me do what I wanted to do and needed to do, and that's been true all along. Just, it gets better and better.
Oh, I love that. So you're now doing an honors. So what's the honors in?
So it's honors in computer science. The project was kind of bioinformatics-y, but on the people side. It was more about I didn't have the terminology for it then, but it was really about user interfaces more than it was about bioinformatics. And I kind of muddled through honours. It was the hardest thing I'd ever had to do. It was the first time I'd really had to work, and I worked my ass off, and I got a second class honours, and I was offered a PhD project by Damien Conway, who is an extraordinary human being, and we got along really well. He'd been one of my lecturers in honours, and he had this project in computer science education and designing a programming language for teaching programming. And it sounded really interesting, and he scavenged up some money for me, and away we went. And it was amazing.
Oh my God. And I have somehow left out the part that you're a doctor. Like, did I completely skip that?
Like, yeah, I have a PhD. I am Dr. McIver.
I'm very sorry for skipping past that, but oh my God, yes, sorry. Should have introduced you as you should have been introduced. Oh, that is terrible. But talk to me about the PhD. How was that? Like, I mean, it sounds amazing, and it sounds like such an important thing to be doing. Like, how did you find that? Like, what were you even doing? Like, how does that go about? Like, what do you do? Sorry, I've got so many questions now. Just talk to me, Linda.
It was quite the saga. First of all, working with Damien was fabulous. He's an amazing man, and I learnt a lot of my teacher craft from him, because he's an amazing teacher. But the project itself, it sort of had a bunch of parts, and the whole usability, user interface thing came back into it, because one of the big issues with learning programming is that programming languages tend to suck. They're designed by intense tech nerds for intense tech nerds, and it makes them quite inaccessible for novices and normal people who aren't intense tech nerds. And so the first part was, well, actually see if you can find out what's usable. What does usable programming look like? What's a language look like that's actually intelligible to human beings? So there was some testing in that, and I went and wrote a standard introductory programming exercise in about 14 different programming languages, which completely broke my brain, and I can recommend completely breaking your brain on a regular basis. It's very, very good exercise. Wonderful for staving off dementia. So I did that, and then I designed a language and I tested it. I sort of ran the same exercises with one bunch of kids in my language, and I called the language Grail, which stood for Genuinely Readable and Intuitive Language. So I wasn't smug at all. And by the end of the project, I found that yes, having a good programming interface made it much easier. Well, okay, I have to be careful the claims I make. What I proved was you make less errors with a programming language that is more readable and understandable. That doesn't necessarily mean it's better for programming, doesn't necessarily mean it's easier to learn. What I proved was you make less errors. You can, there's more things to do from that. And I found out actually just recently that someone has done some of those more things and done them really well, like, based on my thesis, which is just very exciting.
That is so cool to hear.
My cat's just come to join me. But the one thing I knew by the end of that project was that a teaching language was the absolute wrong way to go, was the worst way to teach programming. And the reason for that is because the biggest barrier to learning programming is motivation. If you don't have a really strong reason to do it, you're not going to get past the frustrations. And it doesn't matter how well designed the programming language is, there are going to be frustrations.
Yeah.
So the most important thing is to give people real things to do, things they care about, things they can see the point of, and things that they want to do. And if they've got that, then they will push through any barriers. And absolutely we should be reducing those barriers. But if you don't have motivation, you've got nothing. So that really shaped everything from there.
That's such an interesting point, I think. And it lines up in and of itself with teaching. Like, I mean, yes, there's definitely people who prefer the kind of rote method of like, well, I gotta learn this, gotta do a test, gotta move on. And there was times where I was completely like that. Like, I mean, I think learned off, not even joking, pages of essays in history. I don't know how. I would just practice writing them in. I'd just like have the memory of having written 4 pages. So I would spit out 4 pages in the exam, and that was that. But when it came to things like maths, I literally had to sit there and I'm like, I cannot rote learn like a theorem. I'm like, I need to know why this links to this, to this, to this. Like, I don't understand otherwise. And it's such an interesting shift where, like, if you're not being taught for a reason, like the whole thing where people are like, I've never in my life had to use X or like an algebra thing. And I'm like, that doesn't sound right to me. I'm pretty sure you do that every day, but you just don't think about it as X. But like, it's so, I mean, it completely makes sense that it would translate towards coding or whatever else it might be as well. Like, it makes sense when you look at it in like the bigger picture retroactively, but glad that you got there.
It applies to the entire education system. My oldest would come home during year 10 math methods and say, why am I learning surds? I hate them and I can't see the point. When am I ever going to use them? And I couldn't answer her. I was like, sorry, you're probably not. Like,
and do you know what the funniest thing about this is? Sorry, just to interrupt this, but you just said surds, and someone who's done a maths degree, I literally for like a full 30 seconds was like, what the hell are surds? Like, what?
Right.
Like, I don't even remember that.
Not an obviously useful concept at all. But then she also came home asking the same thing about calculus. And my husband's an electrical engineer, and he said, I use that all the time in my work. And he sat down and showed her how he used it. And she was like, this is amazing. This is so cool. Why don't they tell us this?
Yeah.
So all of these experiences kind of built in my brain towards, we really should be teaching with real stuff. We really need to give the kids an understanding of why they're learning things and why would they care?
I like that. Oh, so you've now come out of the PhD and what's next?
So the PhD took a while because I got sick. I got actually what it looks very much like long COVID, only it was some other virus. They called it at the time post-viral syndrome. A lot of people didn't believe it was a thing because it's not visible. Like, you don't have spots on your face or lumps or, but I was pretty sick. And so the PhD took a while. And I ran out of scholarship while I was doing that. So I took a job as an academic. I started out as an assistant lecturer and then went on to lecturing. And so by the end of the PhD, I was lecturing full time and I just kept doing that. And I really loved the lecturing, but I didn't love the research. I couldn't find a way through. I couldn't find a topic I was passionate about, or it didn't feel like my research was making a difference. So I was doing research in usability and I was doing research in computer science education, and I just didn't feel like it mattered.
Yeah.
I could have stopped doing it tomorrow and no one would notice. And then Monash had a round of redundancies. They were getting rid of a third of the staff, I think, and the workload was staying the same. Like, there was the same amount of work to do. And I had already struggled. I'd come back from my first round of maternity leave with my first child and struggled to come back even half time. And then I was pregnant with my second when this happened, and they were like, okay, so, we're getting rid of a lot of people. Your workload's going to go up. I was like, I don't think I'm up for that. I didn't think I was obsessed enough with research to make a go of it. You have to be pretty driven to make a go of it in research. And I wanted to spend time with my kids and have a life as well as a job, which is a bit radical, I know. But,
wild thoughts here now, Linda. Like, I don't know where you're coming up with these.
So, and I hadn't intended to leave, but they had, they were like, you can inquire as to what your package would look like if you were to take a package with no prejudice as to the outcome. And I looked, and it was going to be a year's salary. And I was like, that actually works for me right now. Heavily pregnant with my second child. Let's do that. Because there wasn't any paid maternity leave at the time.
Oh, of course. Okay. So I love how the options were do double the workload of what it was before, or go home and take a year worth of it.
Yeah, that's like that works. So I took that package, and I spent a couple of years just at home with the kiddos, and then I started doing some freelance writing. I did some pro bono communications work for Oxfam Australia. I was a project officer for the breastfeeding friendly workplace accreditation program. I was, trying a lot of things.
Yeah.
And then a former colleague from Monash called me up and said, "Hey, we're doing this thing that I think you're going to be kind of interested in." And I went, "I'm not coming back, right?" And he went, "Hear me out." And I remember taking the call. My youngest was in the bath, so I'm kneeling on the floor of the bathroom, phone under the chin, wrangling the munchkin in the bath. And he told me that they were there was this science school opening up, and they were developing a new computer science curriculum for science nerds. And I was like, oh. So next day, I started working for him, developing the curriculum and resources to go with it. After doing that for a year, I was teaching there because I just got sort of sucked further and further into the classroom, and I just loved it. Like, that sense of immediate impact was really intense. And in fact, the first class I ever took there was, they do a kind of introduction to the next year, like a Head Start program in December for year 11 and 12. So that was my first class of year 11s, and there are no bells at that school. And so we were having a wonderful time discussing the nature of intelligence, because I decided to start with an artificial intelligence unit, and we're chatting away and deeply into the discussion, and another teacher comes in and goes, "Is this a period 2 class?" I'm like, "Yep." And she's like, "It's halfway through period 3. We're looking for your students." I was like, "Oh, sorry."
But that is amazing to hear, though.
I was so engrossed in it, and we were having a wonderful time. So, yeah.
No, like that, it screams the passion bit that you were talking about. Like, I mean, it all fits in, and like everything kind of like this seems like it's lining itself up to being the right position at the right time.
Yeah, absolutely. 100%. So I got to develop this entirely new curriculum for the year 11s, which was an introduction to computer science, and it was basically I developed it with another teacher there, Victor Rajewski, and we basically put in everything that we found interesting. So we did artificial intelligence, we did ethics, visualization, computational science, data analysis, algorithms, and Python coding, and usability, a big unit on usability, which was my absolute baby. And they hated it. They hated the unit on usability. But they come to me now, years later, and go, "That was the most useful thing I ever did. And I did a course on software engineering. We never did usability again. But I can't look at a website or a bit of software or even a door handle without thinking about usability now," which is kind of a bit of a love-hate thing. They're like, "Damn you, you've ruined me." But at the same time, there's this whole generation of students out there who've gone into software engineering and who are actually thinking about usability when they design systems. So I'm very proud of that.
I'm sorry, that is like the most inspiring thing I've ever heard. Like, to have that impact. Like, I mean, I definitely do that. Where, like, I mean, there's been so many people that I've chatted to over my life where I'm like, I'll think about them every so often. I'm like, I'll do something, and I'm like, that's what I want. I'm like, I want someone to think about that one time. Don't know what it'll be about. We'll figure that bit out later. But like, it sounds amazing, and I think it's like, of all the things, like, I'm glad it was usability. Like, it could have been AI, or it could have been like ethics would have been just as good. That's not a lie. But it's such an important part, and I'm so glad that that's stuck in their head, and it's also becoming a lot more commonplace to be thinking about and talking about now. and hoping
Yes.
that there is more of that in college now. Please God.
I hope so, but I wouldn't like to make any bets on it.
Yeah, exactly. That's very true. I see some of the things out there and I'm like, oh, definitely isn't a thing yet because I'm seeing this. But anyway, sorry, take me back into the school. So it's thriving along. People are learning, clearly really learning because they're coming back 2 years later.
So the other thing we did in that year 11 course was we did what we called the computational science assignment, where from the beginning we worked with scientists to solve their computational and data needs. Always on the understanding that this is a student project, no guarantees of anything useful at the end, but worth a try kind of thing. And that first year we had a marine biology project on seals and a cancer research project. And one of the cancer research groups actually made a material difference to the researcher we were working with, to his research. And I think he might even still be using that software today. This was in 2011. So they actually, he had enough computer science to know what he needed, but not enough to do it and not enough time. And so he just threw the problem at these kids, Matt and Chris, and they went nuts. It was amazing.
And these are year 11 kids.
Yeah. So I had year 11s doing cancer research. I was like, "Oop, I'm done. I can't top this. I might as well quit now."
You're living like literally as far oh, but that is outstanding. That's amazing to hear. I think I don't have words for this. I'm in awe. Like, this is amazing. Like, I think I'm compared this to, like, we had a very similar thing like that where we had statistical consulting in college and like a 4th year module where it was kind of our final year project and things like that, where we had like external like industry people being like, hey, here's our data. If you can do something, that's great. Like, obviously the actual analysis and stuff was done by the lecturer and she gave it back, but we all got to do it as well. We got access to the data. But this is so much cooler. And also in year 11, where like it's such a good part of life to be like, oh, I see what the impact of this could be and I can go try something completely different, like putting them onto a whole new path, which is amazing to hear. But I'll give it back to you.
It was pretty phenomenal. At the same time, in year 10, we were teaching with toys, and that was not my subject. I didn't have control over what we taught. And we were teaching, year 10 was a core subject, so every year 10 at this school had to do this subject, whereas the year 11 was elective. And in year 10, we were teaching kids to use Scratch-based interfaces to draw pretty pictures, push robots out of circles, stuff like that. Meaningless toy stuff was supposed to be fun. And the single most common bit of feedback I was getting was, why are you making me do this? This is not relevant to me. I can't do it. I hate it. And I'm never going to use it again. Why are you making me do this? And eventually I persuaded the teacher in charge of that subject to go with a small data science unit, just as a little test. And it completely changed everything. And the first unit was a mess. It was flawed. We didn't have enough teachers who really had the skills to teach it. The resources weren't, were very version 1. But they loved it. We worked with election data. It was 3 million lines of CSV. You couldn't even open it in Excel, so we had to code. Gosh darn it. Sorry, not sorry. And they kept coming to me going, this is amazing. I used this in my science project and I used it in my maths exam, and oh my God, there was this graph on the news last night and it was outrageous. It was so misleading because there was no 0 on the scale, and like they could see the point. And we went through 3 more versions of that unit. We did one on microbats, the one on election data, and one on climate science. And it didn't matter what the data set was, it just mattered that it was real. We were teaching the same coding skills, functions and variables and iteration and selection and all that jazz. But it was meaningful. And they learnt some data literacy, and most of the visualizations they did by hand. So they really didn't do a lot of code. They did just enough to pull the data out of the file and analyze it a little bit. And then they did the visualizations by hand because it was easier to make them compelling. And it just completely turned around their attitude. So that's when I quit.
I'm just like, I'm so glad we had this chat, because I'm like, this is exactly what I wanted to talk about. And like, that was brilliant. But I think it's just so interesting where, like, when someone came back about the zero and like there was no leading zero and like the graphs being, and you look at the world right now where what's it called, fake news and the data literacy, I feel like is at an all-time low somehow. It's absolutely bizarre, and just like in the age of information that we call it right now, to be at that level, it's a sad state of affairs, to say the least. But
and it's an essential skill. And if you look at the curriculum, we teach, the maths teacher. I was working with a maths teacher on the first version of the unit. She was like, why are you doing this? We already do graphs in maths. But what they do in maths is they say continuous data needs a linear graph, a line graph. Discrete data needs a bar chart. Here is how to draw a bar chart. Here is how to draw a line graph. You are done. And that's how I was taught. Like that. I'm like, yep, that reminds me of school. Like, yep. It's not useful. It's not communicating results. It's not, sometimes you actually do need to put discrete data in a line graph. Like, it depends what you're trying to show. It depends what point you're trying to get across. It depends which aspect of the data you're trying to highlight. It depends what your question is of the data and what answer you found. And graphing is a form of communication. We need to teach it as a communication skill. So just that basic, here are the technicalities of the graphs. It doesn't do it justice at all.
And it's like, I mean, even just listening to that, and it's such a clear thing of like, if you don't even realize that part of it, right? Like, if you don't realize that this is a way of communicating, or you can make it do what you want it to do, you don't realize that there's ways to manipulate it to show you something that you shouldn't be seeing, and that there is fake ways you can make it up. And we're like, well, this data says this, and you're like, I'm pretty sure, like, I don't know, I feel like I'm definitely, like, it's the classic one of like, oh, if you have an ice cream, you're gonna have a cat like die like early or something like that. I can't remember what the data set example is off the top of my head. But like, it's something so innocuous in terms of like causation isn't correlation, those kind of things, where it's just like, if you can't put like, and it's like, if you're not taught that there is ways around this, or like this can be a thing, you're never gonna question it. Like, it's it's such a like continuous thing of like, you need to see it. But sorry, you quit.
And you need to see it in real data, because if you look at the textbook data sets that we work with, if we ever work with data in schools, textbook data sets give you a perfect curve. They come out with a nice, neat summary statistics. They do exactly what they're expected to do every time, which is the one thing you can guarantee a real data set will never do. So we're not, and I'm hearing from people who have masters in data science who have never used data sets that are complex and where there's no right or wrong answer. And what's the point of a master's in data science if you're not using real data and learning that, what do I do when things are a bit fuzzy? What do I do with outliers where I'm not sure whether they're genuine outliers or whether they're mistakes in the data? How do I cope when it doesn't come out the way I expect it to come out? Those are essential skills, and we're not teaching them. We're teaching it as some kind of pure, perfect science, which is the worst possible message we can be getting across about data science. It is not a pure, perfect science. It is a mess. And the first question you need to ask about data is, what's wrong with the data? And if I teach nothing else, that's my big one.
It's just like, I don't think I've ever tried to do anything in data science and it's come out right. I'm so
exactly.
I never, like, even in school or like college, I was like, this doesn't look right. What have I done? But I'm glad that was the case, because I'm like, well, I'm used to having that kind of, like, it's such a good thing to be like used to be like, okay, I know I've done something wrong. It's now like, I've got the bare bones. Let's try and fix it again. But like, God, I feel like we could talk about this kind of stuff all day. But
yes,
you quit. You did all this great stuff.
I quit. Yeah. So I quit because I wanted every student to have that opportunity, not just the kids in my classes. And it was clear to me at that point that this is how you get kids engaged with STEM. You show them that they can solve real problems with it. That's how you tell them that it's worth doing. You don't throw them in with robots for a day and go, hey, we did STEM. You don't give them a makerspace and say, this is STEM. You give them something real to do. That's what STEM is for, right? Science, technology, engineering, and maths are for solving real problems. Give them real problems to solve. It's not that hard to do. It's not rocket science, but it's not done. It's really not done. So I started the Australian Data Science Education Institute, which has, the whole goal is it's a charity dedicated to building data science and data literacy skills. And we train teachers because it scales better than working directly with kids. If you work with 30 kids, you've just worked with 30 kids. But if you work with 30 teachers, then ideally you've impacted every student they ever teach from then on. And we develop resources and we find cool data sets and annotate them and write lesson plans around them and stuff like that.
And so for this was exactly the stuff that I started hearing about when you got up and we're like, hey, we're looking for other people, or if we're looking for data sets and stuff, if you have any. And I was just like, you're doing what? This is the kind of stuff that I never had as a kid, which I would have loved, looking back as somebody in tech who found their way into it but didn't know that was a thing. I'm like, oh my god, amazing, this is great. And I think anyway, whatever I think, it's just going to be me repeating what I've already said in the last half hour.
But I hear that all the time. People going, oh my god, can you do that in schools? And when I first started ADSEI, I was like, not yet, but give me a minute. And now it's like, we're building this. It's not built into the curriculum, but it's a thing that you can do. And everyone's like, oh man, where were you when I was going through school? And can you talk to my kids' school? People get very excited about it. It's great. It's really, really heartening.
Oh, I love it. And how is that all going now? So I know that you were, sorry, I thought it dropped out again, my head. Oh, I thought this call nearly dropped and I was about to cry. But how is that going now?
Yeah, it's going really well. So I took the opportunity of all the lockdowns and stuff to write a book.
I was going to get to that next. I was like, perfect timing.
Well, the book has changed a lot of things because getting the book out has really raised the profile of the work that we're doing. And I'm now, I used to be sort of going to schools and saying we should do stuff and kind of dragging them in. And now I'm getting, I'm people are seeking me out, which is awesome. So I'm getting schools contacting me going, hey, can you help me put data science into my curriculum? Hey, can you find me a cool data set? Let's, can you train my science teachers to do data stuff in the course of their science projects? And it's great. It's really kind of kicked things up several notches, which is really good. The book is really about critical thinking as much as anything, which is why it's called Raising Heretics. Teaching kids to change the world. It's like, give them real stuff to do. They want to do real things. Kids are intensely passionate about justice and about the environment and about their communities, and they want to fix things, and we tell them to kind of sit down and shut up and do what they're told, and we'll let them, they might be able to fix things when they're an adult, maybe, but we'd probably prefer they didn't. Let them fix things now. They are a powerhouse. Why are we not, empowering them?
I mean, there's year 11 kids solving cancer problems. So I mean, I think we'll be fine if we give it over to the kids a little bit.
Right.
Especially in the context of what most adults are doing. I'm just like, I think we can hand it over a bit. I'm okay with that idea.
Yeah, but there's a reason for that, which is that schools are really good at churning people out who follow the process and who do what they're told and who sit down and shut up. And as a person who's never been very good at doing what she was told or at sitting down and shutting up, I found that really constraining. And I could see the same thing happening to my kids and also to my students. Whereas you give them something to do, you give them scope to fly, and it's phenomenal how far and how high they can fly. It's just breathtaking. You got to give them a reason. You got to give them something real to do. The change is incredible.
It's so amazing to hear, I think. And I mean, honestly, if you haven't gone out and got the book yet, definitely do it, especially if you've got kids. I think it's such an important one to be able to read through and understand that part of it, because it goes back to if you never had that growing up, right? Where I mean, I never did, in that context of oh yeah, you can go do work problems and go do them now. It's definitely something where it's a kind of an eye-opener. We're like, oh, okay, no, wait, no. I need to change my thinking here a little bit to help out the other bits of it. Definitely go get onto that. I think it's important. But I think it's just like, I mean, and I knew like you'd been in the, like, I mean, I knew you had a PhD in computer science and things like that. So like, it's not necessarily an untraditional pathway into technology, but like, I think you've had the most untraditional career in technology, which I think is still part of the whole podcast. Like, I mean, these are the reasons we get into tech and like the idea, like the big world ideas of like, yes, we can change the world and you can do everything with tech, but this is kind of the heart of it, where it's like, well, how could we make it better going forward?
Yeah, and one of the things that I noticed, so the first time we ran a data science project for the year 10s, the number and composition of the year 11 class changed. So we doubled the number of girls, which, you know, went from 5 to 10, so let's not get too excited. But we had never, you know, in like six years to that point, we'd never got more than 5 girls. So that was massive. But then also we got a lot more boys too. So that really rammed home to me that we can see that we're not getting girls in technology because it's a really easy thing to measure, right? But what we don't see is the boys who aren't coming into technology because they don't see it as interesting or relevant, or they can't see the point. And the non-binary kids who don't see themselves represented at all and don't have a pathway because they're not, you know, they don't go to girls events and they don't see themselves represented in tech, and so they, you know, quietly slip away. Some of those kids are going to be amazing technologists. Not all of them, but some of them are going to be amazing if they just find the pathway in. And this gives them a pathway. This gives them a taste of it. Everybody should try it. Everybody should try it and achieve some success. And then if they choose something else, no problem. But if they've never tried it, they've never been given an opportunity to play with it, never given an opportunity to see the point of it, and never really had the tools to succeed, then of course they're not going to go into it. And so you wind up with a computer science and a technology industry that have the kind of people we already have. And it's very good at attracting the kind of people we already have. But we need more than that. We need better than that. We need that diversity.
Honestly, I'm literally just going to record this snippet and that's what I'm going to put out anytime someone asks me about this. I'm like, no, I don't need to say anything more. Because that is exactly it. And this is the best way I've heard, like, honestly, like the most succinct way I've heard it being put in terms of why it's a necessary thing. And honestly, I can't think of a better way to wrap it all up. I think that was like a really good way of like encapsulating it all. And I know for a fact there's a lot of data people that listen to this, mostly because a lot of my connections are data people that get notified about this by me spamming it on people's pages. If you have data sets and you have access to things, send them out. I know Linda would appreciate any access to all of them.
Yes, please. Interesting data sets, particularly if they're annotated, so that I don't have to spend hours trying to figure out what every column means, which is often a problem, especially with scientific data sets, where that, you know, you get columns that are labeled H55B, and you're like, what does that even mean? So, you know, data sets that are annotated with how they were collected and what each field means and how they're related to each other, that they are gold, absolute gold.
And I'm sure there's more than enough people listening that probably have access to one or two of those kind of things, or have seen something where they can get their hands on it. So do your little part in getting pathways existing for other people out there into technology, I think is the right way about putting it. Linda, thank you so much for sharing. I'll put all the links and stuff to where you can get the book and where they can come check out all the work you're doing, so people can come and listen. But thank you so much for your time.
Awesome. Thanks so much for having me on the podcast. It's been a really fun chat.
It's been a long time coming, and I'm very glad to have gotten to hear the whole background behind how everything happened. Because I already knew the front bits, but I'm glad I got to know how it got to the front bits, which involved all the great stuff that you did, and then quitting bits. I loved it. This was perfect. But look, we'll leave it off there today. We'll be back again in 2 weeks' time with another episode. If you've been listening so far, please review. It does help. Review, like, share, do all the things that all the YouTubers say, and I feel weird saying, but please do it. It actually does help at the end of the day. And you can go support the podcast on the website. All the links for everything from all Linda's stuff that we talked about will be somewhere attached to this episode. So take care in the meantime, and we'll see you again in 2 weeks.